Hi, so this is a video on the search algorithm CA. Very quick introduction of myself. I'm Renzi. I'm a part-time KA student working in ST Electronics as a research engineer. In ST Electronics, I'm in the space system department, and in this video, I'd like to show you how we actually use search to actually solve some of our real-world problem. As you can see here, this is a brief outline of what I'll be going through. I'll first give an introduction to search, mainly in the aspect of greedy search and taboo, and we'll share with you one of these very famous problem that we face in our domain called the satellite shedding problem, and how we actually use search algorithm to solve it. Hi, so a good way to understand search is to introduce a problem called the knapsack problem. So imagine we have a thief and he's carrying a backpack, and this backpack actually has a carrying capacity constraint of 10 kg. He enters an unattended shop, and the shop has 4 items: a gold bar, bowling ball, a rice bag, a sack of rice, and a dictionary. So if the thief is smart, right, he will immediately choose the gold bar and dictionary, put inside his backpack, and run away. Because these two combination items will actually give him the most value for money, while at the same time it satisfy its backpack carrying capacity constraint. So we can more formally describe the knapsack problem as such, where we can define the store as an array of items, and there is a value and weight attributed to each item. So we can define a carrying capacity constraint where we equate it to C, and this knapsack problem is in fact actually part of actually a larger domain or problem called combinatorial optimization problem. So there are 3 primary searches: brute force, greedy, and taboo. And in this presentation, I will talk about greedy and taboo more because it's pertinent to the satellite scheduling problem that I'm going to show later. So, okay, greedy search is actually very often used as an introduction to heuristics in computer science, and the idea is actually to start from the largest item and then move on to the second largest until the constraint is being met. So applying to our store example, we will then define a density function where we take the ratio of the value and weight, and we calculate this density for each item, and then we will pick we sort it, and we'll pick the top few until we just keep on picking the top few entries until the carrying capacity constraint actually being met. And from here, we can actually see that you actually pick up the most optimum one as the one that the smart thief has picked up. So the good thing about the greedy algorithm and why is it so popular is that it's simple and it's highly efficient. As you can see here, that it's actually linear in both time and space. However, a greedy search is what we call a local optimization search. So it's actually unable to solve more complex problem and give it the global minimum. So for example, we can illustrate it by looking at a hill climbing example. Imagine we start off at position A. Using a greedy, we will only get stuck at small m, and we will never ever be able to reach the global minimum at big M down here. So therefore, we need to introduce a stronger algorithm that is called the taboo search. So the big idea of taboo search is to introduce this list called the taboo list, where we block off certain moves so that we can actually kick it out of this local minimum. So the taboo search is actually proven to be able to solve like multiple problems, NP-hard problems, which is very common in our real-world cases, such as scheduling, graph optimization, logic, and AI. So in summary, this is a comparison between greedy and taboo. And these are actually some of the real-world application where searches is actually being used to actually solve this type of real-world problem. So over here, I'd like to show you the Python script that I actually wrote to actually implement the shadowing, the search to solve the satellite shadowing problem. So over here is actually the main script that I've written for the company, and all you need to do is actually to uncomment the type of algorithm that you want to use, and we just run it. So over here, we just press enter. You can see you start to run, and you start to generate all the search out. So I actually use the object-oriented programming paradigm to actually model my satellite and imaging tasks. So this is actually the script that contains most of the code in doing so that will make my problem a lot easier to solve. And this is actually the different type of strategies that I actually implemented such that it's able to aid in the searching. So we have the very simple one like first come first serve, greedy, and also taboo. Okay, so here is the plotting of the results that the greedy actually returns. So the green are the targets that are supposed to be taken, and the red one are the one that are taken for that orbit. So as you can see, it took a few and it downlinked. When the satellite reaches carrying capacity, it will start to look for a ground station to download the satellite imaging data. Yep, so I've come to the end of my presentation. I hope you take away something and know a little bit more about search and how it can be used in real-world business problem. Thank you very much.